Hello dear student, welcome to your channel Impulse JEE for Learning Physics. मैं आपका मेंटर प्रकाश रंजन हूँ। डियर स्टूडेंट, मैं आज आप लोगों के साथ स्विमर्स प्रॉब्लम बोलूँ या रिवर्स प्रॉब्लम या बोट प्रॉब्लम, मैं कुछ कंसेप्ट और प्रॉब्लम को डिस्कस करने जा रहा हूँ। आई नो आप लोगों ने ऑलरेडी तो स्विमर्स एंड रिवर्स प्रॉब्लम को पढ़ लिया होगा इन काइनेमेटिक्स। स्टिल कुछ स्टूडेंट ने रिक्वेस्ट किया कि सर फिर से थोड़ा आप एक्सप्लेन कर दो, जिसके लिए मैंने सोचा कि इसको थोड़ा सा डिफरेंट तरीके से हम लोग फिर से देखते हैं। जो ऑलरेडी स्विमर्स प्रॉब्लम कर चुके हैं, जो मेरे चैनल के थ्रू कंसेप्ट को बूस्ट कर रहे होंगे, उनको भी मैं बोलना चाहूंगा कि आप बड़े ध्यान से वीडियो को देखो। सबका अपना वे ऑफ थिंकिंग होता है और सॉल्विंग स्किल होता है। तो हो सकता है अगर आप ऐसे नहीं सोच रहे थे पहले लेंदी वे में अगर आप क्वेश्चन को सॉल्व कर रहे थे, तो आई थिंक मेरे इस एक्सप्लेनेशन से डेफिनेटली अननेसेसरी कैलकुलस को आप अवॉइड कर सकते हो और डायरेक्टली इन डिफरेंट वे ऑफ थिंकिंग क्वेश्चंस को इजीली एंड सिंपल तरीके से सॉल्व कर सकते हैं। तो चलिए स्विमर्स प्रॉब्लम का एक क्वेश्चन सबसे पहले बोल देता हूँ, जिसको कि आप सभी को शायद देख भी पा रहे होंगे। बट इस क्वेश्चन में देखिए स्विमर का वॉकिंग भी दे रखा है। क्यों ऐसा कह रहे हैं? तो अगर आप स्विमर प्रॉब्लम को पहले से पढ़े होंगे तो जस्ट मैं थोड़ा सा ब्रीफ कर दे रहा हूँ। इसके बाद वो क्वेश्चन को हम लोग टेकअप करेंगे, फिर इरोडोव के भी क्वेश्चंस का मैं एप्लीकेशन बताऊंगा कि इजीली कैसे हम लोग उसको सॉल्व कर सकते हैं। तो देखिए, जो आपने बेसिक से एकदम स्विमर्स प्रॉब्लम को किया होगा, उसमें आपने एक स्विमर का विथ रिस्पेक्ट टू वाटर स्पीड लिया होगा एंड वाटर का स्पीड हम लोग मान लिया है हॉरिजॉन्टली है। हम लोग सबसे सिंपल केस लेकर चल रहे हैं, जिसमें विड्थ भी क्या है, कांस्टेंट है और सारे स्पीड भी कांस्टेंट है। तो इसमें अगर आप देखो तो ये स्विमर जो है वाटर के रिस्पेक्ट में स्विम करेगा, बट ये इसका मोशन जो है ऑब्जर्वर पे डिपेंड करेगा। कोई ऑब्जर्वर जब ग्राउंड से देखेगा तो इसका वेलोसिटी डिफिनेटली आप ग्राउंड से ही ऑब्जर्व कर पाओगे, जिसके लिए इस दोनों का वेक्टर रिजल्टेंट के अकॉर्डिंग मैंने यहाँ पर इसके डायरेक्शन को बता रखा है कि VAC इज द वेलोसिटी ऑफ स्विमर विद रिस्पेक्ट टू द ग्राउंड। सबका मीनिंग मैंने यहाँ पर लिख भी रखा है, जिसको आप रीड आउट कर सकते हो। और कहीं ना कहीं जो है स्विमर जाकर ए पॉइंट पे जो है क्रॉस करके रीच करता है, उसका कुछ मैंने कोऑर्डिनेट दे रखा है। बेस्ड ऑन दैट मैंने पोजीशन वेक्टर लिख दिया, जिससे कि आप जो इस एक्सप्रेशन को कैलकुलेट कर पाते हैं और यहीं से सारे कंडीशन को फाइंड आउट करते हैं। लाइक वन हैज टू रीच डायरेक्टली राइट अक्रॉस दिस पॉइंट बी फ्रॉम O to B डायरेक्टली, इट मींस द ड्रिफ्टिंग मास बी जीरो, जिसको आप x जीरो कर देते हो। तो यहाँ से आपका कंडीशन आ जाता है VW by VSW sin थीटा, और यहीं से आपने देखा था कि sin थीटा का वैल्यू कैन नेवर एक्सीड 1, इसीलिए VSW ऑलवेज मस्ट बी ग्रेटर देन VW अगर इसको डायरेक्टली इस पॉइंट पे रीच करना है तो। बट आपके क्वेश्चन में क्या दे रखा है कि उसको डायरेक्टली बी पॉइंट पे रीच करना है बट इन मिनिमम टाइम, जबकि आपने देखा है फॉर द मिनिमम टाइम व्हाट शुड बी द एक्सप्रेशन। So for the expression for the time is d by VSW cos theta. So to minimize the t, cos theta must be maximum, जिसका कि maximum value हम लोग 1 लेते हैं, तो जिसके लिए cos 0 करना पड़ेगा। The swimmer has to swim perpendicular to the velocity of the water, or you can say whatever velocity of the river also. So यहाँ पर आपका मिनिमम टाइम जो है d by VSW आ जाएगा, and we are getting the minimum crossing time only if the swimmer is going to swim in the perpendicular direction of the current, और आप कह सकते हो in the perpendicular direction of velocity of river also। बट यहाँ पे तो कंडीशन दे रखा है आपको कि बाबू O से डायरेक्टली B तक रीच करना है। बट इस केस में क्या हो रहा है कि स्विमर जो है ड्रिफ्ट हो रहा है, मींस यू हैव टू अवॉइड द ड्रिफ्टिंग आल्सो, बट यू हैव टू अटेंड द minimum time also, and this is only possible if swimmer starts walking on this। तो ऐसे अगर आप करने जाओ बेसिक से तो इसमें थीटा और कुछ कैलकुलस में यूज होगा, जिसको आपको डेरिवेटिव लेना होगा, लेकिन इसको हम डिफरेंट तरीके से कैसे सोच सकते हैं मैं इसको बताने जा रहा हूँ। तो चलिए सबसे पहले मैं बेसिक का जो इक्वेशन हम लोगों ने देखा है या आपने भी रिड्यूस किया होगा, उसको मैंने थोड़ा दूसरे तरीके से बोलता हूँ। जैसे आप देखो, आप चाहते हो कि डायरेक्टली जो है स्विमर बी पे रीच करते, विदाउट एनी ट्विस्टिंग, यानी कि आप x को 0 करते हो तो यहां से आप VW माइनस VSW sin थीटा आता है टाइम्स t, तो t कैन नॉट बी इक्वल्स टू 0, तो यहां से sin थीटा का वैल्यू आपको मिलता है v by VSW। तो पहला तो आप समझते हो दिस इज ओनली पॉसिबल मींस स्विमर कैन डायरेक्टली रीच टू b only if VSW must be greater than v, then only swimmer can directly reach the point b। अब इसको हम लोग डिफरेंट तरीके से कैसे देख सकते हैं, तो देखिए since water is moving like this, so you can assume one observer is attached with this water, means in the water frame, then one can say this point B starts moving with V water like this, and the motion of this swimmer with respect to water will be along the same direction in which it has started to head. With respect to the observer in the water frame, what he will say, this point B is moving in this direction and swimmer is directly coming in the direction in which it has started to head and meet at this particular location at any time t. So the distance traveled by this will be t and this also by t. So from here also in this triangle, if you write down the sin theta, this sin theta is again coming to this value. Means whatever the expression you are going to get after writing so many expression, directly also we can say if you are going to observe this phenomena in the water frame. So what will be the approach now? So here also the approach remains the same. Here what we have to see is, suppose this is a river and say this is the point B and this is the O, and one has to be directly here. We have seen in order to reach the directly opposite end, time was not minimum, but in this case we have to find the minimum time also. If you have to go to B in the minimum time, then if you look in the frame of the water also, then what we can say, then this observer will again observe that this point B is moving in this direction, and the swimmer after reaching to the opposite end starts walking in this way, while point B will be keep on moving in this direction. So this point B would be moving with this B water, while this person with respect to this observer would be moving with Vm plus V water. So we have to find out the condition in which it can take the minimum time to reach the point B. So what we can say, swimmer is swimming with VSW, is velocity of swimmer with respect to water in this way and going in this way, and it has to reach a certain point in the minimum time. Means this is speed in the water frame. I'm writing in water frame. Then we can say this is Vm plus EW. So suppose if this angle is theta, then one can say this angle will be also theta. Means this angle is theta. And if you know the concept behind the minimum time, that light always takes a minimum time to go from one point to the other point. So if you think in that way, then you can avoid the unnecessary calculus part, and which will be the lengthy also. So directly what we can say, one has to go from here and to reach up to this point, then it has to travel according to the light. So here you can apply the Snell's law. What we can say, mu1 sin theta I is equals to mu2 sin theta t, where theta is the angle of incidence and theta t is the angle of transmittance, or you can say angle of refraction. Also, you know, this is c by v1 times sin theta I is equals to c by v2 times sin theta t. So here we are getting v2 sin theta I is equals to v1 sin theta t. So with the help of this expression, what we can say, if this angle is your theta I and this is your theta t, which is your 90 degree. So what we can say, this would be your v1, isn't it? And this will be your v2. So from here, what we can write, this angle sin theta must be equals to v1 by v2, which is coming VSW by VM plus V1. So at this angle, if swimmer is going to swim, then it will take the minimum time. And suppose if the width is given D, then you can find the minimum time also, because what will be the minimum time? Then to reach from here to here, easily you can calculate. And that will be how much? D by TSW cos theta. Like earlier we have seen the explanation. From here, in similar way to reaching from opposite end, we can directly find out the time D by component of this velocity of streamer, that is VSW cos theta. So from reaching here to here, we have calculated the time. Now we have to calculate this additional time. And just to cross the river, we can write the crossing time of the river, that will be D by VSW cos theta, like earlier. Additional time is for the walking. So whatever drifting would be there. So while the swimmer is going to drift, then the responsible is the velocity of water also. Like we have seen this expression for the X. Whatever the drifting would be there during the swimming, this additional distance has to be covered by the swimmer by the walking. So the swimmer is walking with the speed Vn. So what we can write, Vw minus VSW sin theta times T is VSW cos theta. This is the distance traveled divided by walking speed. This is the expression for the time to reach the opposite point B, but you have to find out the minimum time. Then accordingly, we need to substitute this particular value of the theta. So according to the given data in the question, now I think directly you can find this value of the theta. Width is not given, but suppose if width is also given, then directly you can find this minimum time. So based on such an explanation, I am going to pick the another sum, which is of RE Irodov. I think आप लोगों ने पहले देखा भी होगा, उसका 1.7 का एक सम है, जिसमें आपको क्वेश्चन दे रखा है, आप लोग शायद क्वेश्चन को देख भी रहे होंगे. Two swimmers leave the point A on one bank of the river. Means according to the question, can take like this. So this is a point A. To reach the point B, right across on the other, means directly at opposite end, there is another point B. Means according to the question, it's given. One is going to cross the river along the line AB. means it has to reach directly opposite end. So just we have seen directly to reach opposite end, you know well. Swimmer, I am writing this as a TS swimmer 1. If swimmer 1 has to directly reach at the point B, then there is a certain condition that also we have seen. Here X must be 0. So at this particular angle, swimmer has to swim to directly reach at the opposite point B. So what we can say for swimmer 1, for swimmer 1, sin theta can be written VW by TS1. So what is the value given? The stream velocity is given 2 km per hour. And the velocity of the which swimmer and the velocity of the each swimmer with respect to the water is 2.5. So how much it would be? That is coming 4 by. Okay. Sin theta we are getting 4 by 5. So crossing time would be, we know well, crossing time is d by dsw cos theta that we have seen here. So according to this, what we can write, d by dsw is 0.5. Cos theta value will be 25 minus 16 is 9. The square root of 9 is nothing but 3. 3 by 5. We are getting this time. Means, according to the question, this is the time in which another swimmer also reaches at the point B, but the another swimmer takes some time in walking also. Why? Because it's given in the question, the second swimmer is going to swim in the perpendicular direction of the stream. It is given. Other swims at right angles to the stream. Means suppose if the stream velocity is in this direction, then it is going to swim in this direction, due to which it is going to be drifted. So what we can say, again, if you look in the water film, suppose if any observer is attached in the water, then this point B would be moving in the backward direction with time taken by the swimmer 2 in the reaching from A to B would be simply for swimmer 2. Better to write swimming time. For swimmer 2, what we can say, swimming time would be d by TSW, which is d by 2.5. So during this time, this point B has been moved horizontally. Point B moved horizontally during this time interval would be dw into d by 2.5. Isn't it? Now, again, you can check the point B, suppose is here, which is going with V water. So during this time, point B has moved by this distance, and this has to be covered by the swimmer by the walking. So what we can write? Time of walking in this frame the swimmer is going with Vm plus water. So these are the 2 points. So their relative speed will be nothing but v man only, and the distance separation between them is this. So time of walking we can say would be Vw into d by 2.5 by dm. In the question, it's given both swimmers reaches the destination simultaneously, so their time of motion is remains same. So what we can say, the total time was here 5d by 2.5 times 3, that is equals to d by 2.5 plus v water into d by vm into. See, I have explained you all these things for your better understanding. But once you started to observe the motion in different friends, in which you feel motion is very simple, then directly you could have written in this way. But मेरा पर्पस था कंसेप्ट को आपको अच्छे से समझाना, इसीलिए मैंने इतनी डिटेल से लिखा है. So from here, if you look, then this d and 2.5 is going to get cancelled. So it is coming of 5 by 3 is equals to 1 plus v water is given 2 and v man we have to find it out. So and this is 1. So 2 by vm is coming 5 by 3 minutes, which is 2 by 3. So these two to get cancelled, and from here we are getting vm is 3 kilometer. So I think आपको डिफरेंट फ्रेम में बैठकर मोशन को देखने का कुछ आइडिया लगेगा, आप ऐसे देख पा रहे हैं. नेक्स्ट इरोडोव का ही सम है जो बहुत ही सिंपल है. इरोडोव का सबसे फर्स्ट सम, इसको भी आप वाटर फ्रेम में अगर करने का कोशिश करें तो डायरेक्टली आप बाय लुकिंग एट द क्वेश्चन सॉल्व कर पाएंगे. One boat is going like this. Say this is the velocity of boat with respect to the water, and it is found that at a point A there is a raft. And it is found that at point A there is a raft. And then it is keep on moving. And 16 minutes later it is going to turn back. From here it is going to turn back from this location at t equals to 60 minutes. If you say this is your t0. After some time pass, the raft at a distance L equals to 6 kilometers from the point A. Find the flow velocity, assuming that duty of engine to be constant. What does it mean? Whatever be the velocity of boat with respect to water, that it remains constant. So if any observer is in this water frame, then what he can say, if this boat is going with VW, then it is going to come back with VW only. And whatever be the time is taken from A to say B, same time will be taken from B to A. And while this raft is going to move in, then definitely if you are going to throw any floating object inside the water, and if water is flowing, then that object is going to move with the same speed of the water. So here also, raft is going to move due to the water speed only. And if you attach to the water frame, then raft becomes stationary for you. And what you can feel that for this raft is here only, the boat is going and it is coming down at this point A only. Since the duty of the engine is constant, so whatever be the time is taken 60 minutes, again it will take the same time of 60 minutes. So if you have to find the speed of the water, then what we can say, The distance traveled by this raft is 6 kilometers. We are dealing with the classical mathematics. So we can say time is not going to depend on the frame. So whatever be the time taken by this boat to meet with the raft, that remains same in ground frame also and in water frame also. And since this distance traveled by the raft is nothing but this 6 kilometers, so what we can say? The speed of the water would be 6 by 12, 6 kilometer. So this is coming 3 kilometers. तो आई थिंक डियर स्टूडेंट आप लोगों को बोर्ड प्रॉब्लम कह लो या लीवर प्रॉब्लम का कंसेप्ट डिफरेंट तरीके से अच्छा लगा होगा। काइंडली अच्छा लगे तो मेरे चैनल को आप लाइक करेंगे, सब्सक्राइब करेंगे एंड शेयर करेंगे, जिससे कि मोटिवेशन मेरे लिए भी बना रहे और मैं और अच्छे वीडियो के साथ आप लोगों को अपडेट करूंगा।